If you hear people saying, well, if we lose all our aerosol, if industry shuts down in a day, it's going to climb 10 degrees. This is absurd because, first of all, industry cannot practically shut down in a day. Second of all, the number is more like 0.5 to 1 degree Celsius. Also, the number is highly distributed spatially on the surface. So over the ocean, it'll be a minimal effect. Over continents where there's lots of industry, much larger effects. It's not a uniform process across the surface of the Earth.
Hello, everyone, and welcome to today's Climate Emergency Forum. Today, we're going to be talking to you about a very complex and at times controversial topic. So our title for today is Global Dimming, the Real Deal. So some of you may be asking, well, what the heck is global dimming? I don't even know what that means. While others of you may be saying, I already know about all of this and I'm just watching this to see how much you don't know. Either perspective is fine. All are welcome. And I'm going to start by giving just a brief overview of what is at play when we're speaking of global dimming and some of the primary, shall I say, things, aspects, particles that have to do with global dimming are aerosols. And a lot of you are most familiar with aerosols. Well, you know, maybe this is way back in the day when aerosols, what we knew about them was that they came out of a can when we were using hairspray, which I don't even know if people use that anymore. But yeah, so that may be the extent of your knowledge. And if that's so, that's just fine. And so what I'm going to do is I'm just going to like build on that just a bit, and then we'll let the heavy duty scientists take it away and build even further. But we got to start from someplace, right? So what are aerosols? They're very, very tiny. We can call them particulate matter, particles, pollution, if you will, that linger in our atmosphere. And they have various effects on the climate. They have effects on sunlight, which also have effects on the climate. So I want to just let you know that these particles that can linger for days or weeks, they can do two things. They can either block or reflect the sun. And in doing so, they can have, just in the broadest sense, a warming or cooling effect. So we're going to refer to these as absorbing, meaning they absorb heat, reflecting, they reflect heat. So think of some of these reflective particles as like itty bitty, incy, tiny little mirrors, right? And these mirrors are across the atmosphere, maybe up to the troposphere, and they hang out there with all their little mirror friends, and they're reflecting that sun so it doesn't come through and hit us and warm the earth. Then the absorbing one, these come particularly from coal, they're darker in color. And so we all know that when you wear like a dark clothing, I'm here in New York City, we're famous for wearing black. Some say it keeps us cool, but really it keeps us warm, right? So we like to think we're cool, but all this black clothing is very warming. So when we have particulate matter, especially black in the form of black carbon from the burning of coal or fossil fuels, they hang out in the atmosphere and they hold in the heat, and that's warming. So these are the two primary things that affect our climate. And I am going to let Paul speak to the more specifics about how this affects us and in its relation to the term global dimming. And maybe Paul can start off If you would, I would appreciate it, Paul, if you could let us know even what this term global dimming means.
Okay, thank you for a great introduction there, Regina. So many people in the last month have been exposed to wildfire smoke. Okay, so the ash and pieces of wood that have been partially or completely burned are wafting across North America, for example, from the West Coast fires in BC through to the East Coast. And there's also fires down in California wafting across. So they're being carried by the wind patterns, which are from west to east. The larger particles drop out fairly quickly by gravity, and the smaller particles travel tremendous distances. If you've also had the fortune of having rainfall, then you'll notice that most of the rain, a storm running through clears the air of all of these particles. And you'll also notice that whenever there's a massive storm system going through, you can see much further after the next day because the air is pretty much cleared of the particles. Raindrops falling, they collide with each other, they collide with the particles, they entrap particles. They basically cleanse the air of many, many particles. There's a lot of particles in the air. There's less over the ocean. There's parts of the ocean where you might only have, 10 or 20 to 100 particles per cubic centimeter. Whereas if you go over the land, there's far more particles per cubic centimeter, thousands, 10,000s. If you're near an industrial source like a coal burning power plant or something, then there's many, many particles being produced, and they come up out of the smokestack of these coal burning power plants, and these aerosols, they're in the atmosphere. And basically the lifetime of aerosols in the atmosphere, of course, the larger ones is shorter, the smaller ones have a longer lifetime, but it's about a week because they're in the troposphere. They're in the lower part of the atmosphere, which is from 0 to 17 kilometers at the equator, and it's about 0 to 7 kilometers at the poles. That's the width of the lower atmosphere, the troposphere, where all the weather occurs. Sometimes these particles get up into the stratosphere. Think of a large volcano, putting the particles up in, very, very high up. If it's explosive and pointing upwards, the particles can go right up into the stratosphere. And it takes a long time for them to leave the stratosphere. The smaller ones, it can take several years for them to leave because they're descending a bit because of gravity, but there's turbulence, so it keeps them up there. Basically, all of these aerosols, they do a number of different things depending on their size relative to the wavelength of light. Okay, so they basically either scatter the light, so light comes in, hits them, and then goes off in a different direction. Reflection is a special case of scattering where the light comes in and it reflects back into the direction that it came from. It's a type of scattering, backward scattering. Or the particles absorb sunlight. As Regina mentioned, the black carbon particles from coal are black. The light hits them, it's absorbed into the particle, it heats the particle, and therefore it would heat the atmosphere at the location that the particle is at. So that's well above the ground. But the net effect of all of these particles is the sunlight from the sun, instead of coming and hitting the earth and heating the earth's surface, it hits the particle and can be scattered or reflected or absorbed. Less light is reaching the ground, so there's a general heating of the ground. There's less heating of the ground when these particles are in high number in the atmosphere. And this whole concept is called global dimming. Now, how large is the effect? Okay, well, obviously over the oceans, the effect is very small because there's very few aerosols over the ocean, as I've mentioned. Over land, the more aerosols there are over the land, the larger the effect. So places like China, for example, industrial belts of China, industrial belts of East Germany, over the Soviet Union, there'll be lots of particles generated and therefore lots of aerosols and lots of localized cooling in those regions because of the blocking effect. So it's hard to get an overall number for the entire planet. But if you take the average over the entire planet, the best science that we know of now says that it's about a 0.5 to 1 degree Celsius effect. So if we got rid of all the aerosols, our temperature would go up in the short term until things redistributed and stabilized. So that's the key point. If you hear people saying, well, if we lose all our aerosols, if industry shuts down in a day, it's going to climb 10 degrees. This is absurd because first of all, industry cannot practically shut down in a day. Second of all, the number is more like 0.5 to 1 degree Celsius. Also, the number is highly distributed spatially on the surface. So over the ocean, it'll be a minimal effect. Over continents where there's lots of industry, much larger effects. It's not a uniform process across the surface of the Earth.
Thank you for that, Paul. And you cleared up something that I've heard, or at least I think you did, if I understood you correctly. So I have heard some climate activists say, well, we can never stop burning fossil fuels because we're relying upon these, I don't know if it's sulfur dioxide or whatever it is, not the sulfur dioxide, I forget the exact chemical compound, but that we need the sulfuric acid in the atmosphere in order to counteract the warming that we've done. And if we do stop, as you say, we're doomed. So it's sort of like this idea of like, well, the very thing that's killing us, we must have. But what I hear you saying is that's an absolute fallacy. We don't need to keep it burning fossil fuels.
Yes, that's completely bogus that would happen, that we need to stop burning fossil fuels. If the warming is on the high end of what we think, closer to 1 degree rather than half a degree, of course, that will have a huge impact. So what we can do is we can counteract that effect if we absolutely needed to by having some particles generated in the stratosphere and the upper atmosphere. There's some ideas of putting mirrors on the surface of the Earth to reflect sunlight back into space. This is all fine and dandy if you could get the scalability of it. I'm talking about MEER. But you know, when I put a mirror, try putting a mirror in your backyard. See how long it takes before it's covered in dust, right? I mean, it's not practical to put mirrors around all over the surface of the Earth and have them work in the way they're designed to work because they're going to be covered in dust. So you need to clear the surfaces. I think it's better to put them up in the stratosphere, for example. I'm talking about, you know, a bit of sulfur dioxide, very tiny amounts compared to what any power plant puts out. A fraction of what we put out and pump in presently in the lower atmosphere, but it's got to be in the upper atmosphere. Even better, I think, and this is even more controversial, is, you know, they can be, you could reflect away some sunlight in space if you needed to. And this would, you know, just a tiny amount. It would never be noticeable, but it would just be a small fraction to give us time to slash fossil fuel emissions, to remove CO2 from the atmosphere, and things like that. But it's the idea that we're all going to suddenly fry in a week if we stopped industry is absurd. The idea that we could stop industry instantaneously is absurd. So people should really be concerned about the things that are really a problem and not these wishful thinking, fantasy ideas of doom and destruction.
Thank you for that clarification. Very helpful. And I'm wondering what you think, Dr. Carter, about what Paul just said, and thinking about what we have in the here and now, rather than, you know, these doom and gloom, as we call them, fantasies. Your thoughts?
Thanks both. Very good explanation. Very good coverage. I got involved in aerosol cooling. And by the way, there's only one reference that I can find in the IPCC on dimming. So it's not a term that the scientists really use. And that reference goes back 2007, and it just says aerosol cooling. Some people are calling this dimming. So yeah, I think we've established very well. So the term is really aerosol cooling or aerosol dimming. Now, as has been already well explained, there are many emissions when we burn fossil fuels, and we have to stop burning fossil fuels very fast. And those emissions are black carbon soot. They're black, so they add to heating. They're sulfate, they're shiny, so they reflect away the heating. So when the problem arises as to when we stop burning fossil fuels, now we have to stop burning fossil fuels as soon as is humanly possible. And the global emissions had to be declining, according to all the scientists, on a fast track decline from 2020. So clearly our governments and corporations particularly are making sure that we don't do what we know we have to do for our own future survival. Now, aerosol cooling is important to me because it's part of the commitment. So, and that's a commitment to our children today and to all future generations. We have a commitment of, there's a recent paper actually just been published by some economists who got a commitment if we do what they call a rapid fossil fuel reduction by 2050, and they say that's 2.24 degrees C. And actually that's what I get it to using other methods. So we are in absolute big survival trouble. So whereas in 2007, 0.5 degrees C didn't seem very much because we were at 0.7 degrees C, we're now at about 1.2 degrees C. So you add that 0.5 degrees C to that, that's pretty scary, but it's not the dimming that's scary. What is scary is the amount of CO2 primarily that we have built up in the atmosphere. The amount of CO2 is the highest in 23 million years, and it's accelerating at a rate that it has never accelerated before. That is absolutely terrifying, terrifying. So as Paul has already mentioned, the idea that you're going to get an immediate, and this is not the fault of the public, actually the scientists did this years ago. They imagined that there will be an immediate stop of all fossil fuel emissions, so they had this big sudden blip of warming. And of course, it doesn't work like that at all. And thank goodness the IPCC 1.5 degrees C report settled that one. It's going to be a gradual extra bit of warming over, 2030, 50% reduction of emissions by 2030. The aerosol effect is going to be pretty small. And then it continues smoothly up to 2050. The fastest we can stop fossil fuels, and we have to stop fossil fuels, or we will not survive as a species. Most other species will not. The fastest people think is about 20 years. Now, there is one paper published that puts it at 10 years. And there's a couple of recent government reports, one from the US and one from the UK, and they both said they had surprising results, that they thought that with the technology that we have now, we could get our fossil fuels in as little as 10 years, same as the best case paper that I've looked at. So it's really a non-issue actually, because we have to get our fossil fuels or we will not survive. We have to do it fast. Life is going to be terrible because of all the CO2 we've got in the atmosphere already. This is a dire emergency. If aerosol cooling makes any difference, it just adds to the urgency. It just adds to the urgency.
Thank you so much, Peter. I've mentioned it before, all of this particulate matter, especially from the wildfires. Just a brief aside from the global dimming concept, it's certainly not healthy, as you mentioned, Peter, in terms of human life, and it has tremendously ill effects on the body. But that aside, back to the global dimming issue. So I'm just wondering, Paul, when you spoke to the idea of releasing sulfuric acid one of the other into the atmosphere, these reflective aerosols. So, you know, I always get like a jolt of fear when I think of this whole notion of geoengineering. But as you stated it, these very aerosols are being released anyway, and with the burning of fossil fuels. So if we stopped the burning of fossil fuels, the release of CO2, methane from methane flares, and did indeed release some of these reflective particulate aerosols, that it would not only be a balancing act, but a net positive in terms of cooling?
Yeah, I mean, I think of it as this way, okay? Nobody has a problem with the smokestacks on power plants pumping stuff into the lower atmosphere. So imagine just extending those smokestacks and putting those particulates up into the stratosphere. You know, make really tall ones and put it into the stratosphere. Okay, that would actually change the equation a bit, because instead of all the aerosols, you know, where they are now, I mean, it's sort of like a thought experiment. Okay, it's not practical to do that, but there's lots of particles in the atmosphere. There always has been. Light interacts with the atmosphere, and the wavelength of the light is very short. So when the particles are extremely small, think of the actual nitrogen molecules are very small. So they actually scatter the light. It's called Rayleigh scattering. It goes as the wavelength to the 4th power, the inverse of that. So blue scatters a lot more than red, because blue wavelengths are smaller than red, and they're closer to the size of the particles of the molecules. So the sky is blue as a result, right? As you get larger and larger particles, the type of scattering varies, you know, there's a lot of physics behind it. But the net result is that fossil fuel burning is putting huge numbers of particles into the atmosphere of all different sizes. And the smallest particles are the deadliest to humans. The PM 2.5 particles are particles that are 2.5 micron in diameter or smaller. To give you an idea, the diameter of the human hair is about 50 micron. Mine's probably thicker. You need shears to cut it, not scissors. But basically, so 2.5 micron is smaller, because when you breathe, those go deep into your lungs. They go into the alveoli that exchange oxygen with the blood and take CO2 out of the blood, right? So they get lodged into the sacs, these alveoli sacs deep in the lungs, and they sit there and they can cause cancer. They cause cancers. So 8.7 million people die every year from these emissions from fossil fuel companies, and we just accept it as part of life. Okay, so we need to cut fossil fuel emissions, and that will save all those people's lives, right? And the little bit of warming that comes from it, if it's too much, if it's more than we think, then there's ways that we can counteract it. But that's a sort of a different discussion with the mirror and with these other different ideas. But all I'm saying is, you know, if the and these particles don't last very long in the atmosphere, as you see from the wildfire smoke and so on. And if you go to the other side of the coin, what if we put more and more and more particles in the atmosphere? You know, the worry is that from a nuclear exchange, for example, between Pakistan and India, you know, 40 or so moderate sized nukes from each country going off would send enough particulate matter up into the atmosphere that we would endanger the entire planet's ability to grow crops, because of because of that effect of blocking so much sunlight. So the term is the nuclear winter. Okay, so this is a real thing. With way too many particles, we can block enough sunlight. Enough sunlight would be blocked that we couldn't grow crops for several years. Imagine if that was to happen. So, like, it's not all or nothing. We want to, you know, fossil fuel burning has put tremendous numbers of particles. It's still ongoing. It's still cranking particles up. The numbers are much higher near the industry, of course, near the source. And we're talking about, we need, you know, cutting those down. So yeah, there'll be some warming over the factories that are putting out the particles, because they're going right up above it and blocking sunlight. You know, when the wildfire smoke comes over and it's really thick, we get a drop in temperature. I mean, it's not rocket science. It's just basic, a little bit of, you know, basic, you know, cause and effect. So, you know, we need to slash fossil fuel emissions. We don't have a choice. The greenhouse gases are way too high. The global dimming scare, if you like, is really a bit of a red herring. You know, it's not completely, because, you know, 0.5 degree Celsius effect to 1 degree, but again, it's not over, that will be over localized parts of the planet. So it's, yeah, I've done videos on my channel in the past on this, and there's some very good stuff written about it in all different locations, like Scientist Warning. So don't just listen to one source on this, you know, listen to what the scientists and what the real information is on this.
Thank you for that. I always like the idea of listening to information from more than one source. You know, if you're just following one source, you run the risk of being in that echo chamber, right?
Yeah, it becomes a cult in a way. You know, it really becomes a cult. And then when that source gives you crappy information, everybody believes it. I mean, we've got enough problems with that, you know?
Yeah, we definitely have enough problems with that. Shout out to Facebook and Twitter. I'm wondering, Peter, your thoughts on what Paul just shared with us.
Yeah, I'm so glad that Paul brought up the massive public health crime of continuing to burn fossil fuels when we have absolutely no need to be burning any fossil fuels. Yeah, 8 million people a year are being murdered by the fossil fuel industry. That alone demands that governments phase them out. All that governments have to do, for heaven's sake, is to stop subsidizing them. And within a year, if they charge them some pollution fee, within a year, global emissions will go down, will reverse. They're still going up, like Paul says.
Yeah, and Peter, the 8.7 million people, we should remind the viewers that this, if you're healthy, you're probably not one of those 8.7. It's affecting young children because their lungs are much smaller in size, and the alveoli are much closer to their mouths, of course, and they're much more vulnerable to this type of pollution. Also, anybody with a medical condition, anybody with any lung problem, emphysema, or aging, you know, older people, they're severely affected. So this pollution kills 8.7 million people, but mostly the very young and the very old, the most vulnerable people in our society. And it's like the fossil fuel companies just taking a gun and going and shooting these people, really. They know what they're doing, and they've been doing it for years and years.
Yeah, you mentioned, and it's a good image for people to realize what they have to be scared of. You mentioned that the toxic emissions. Black carbon is a toxin by itself, causes emphysema, chronic lung disease, chronic sinusitis. The acid aerosols, sulfates and nitrates are not only sulfates and nitrates, because there are hundreds of toxic chemicals that are released when you burn fossil fuels, heavy metal, mercury, it goes on and on and on. Now, what happens is that, and it's important to visualize this, and Paul has helped us do that. All of those toxins, minute little amounts, go directly into the bloodstream. We breathe them in, they get down into the alveoli because they're small enough, and then they cross into the blood vessels within the lungs. And then they go into our body everywhere, all right? So it's damaging the health of everyone, Yes, there are those that are more vulnerable, but people have heart attacks and strokes at pretty young ages. I've treated people with very young ages. And of course, the most horrible thing is the babies and children. Babies are very vulnerable to the toxic pollution of fossil fuels, which affects them their entire life through. So I'm really glad that Paul mentioned this, because we do not need any more reasons to know that we have to stop emitting fossil fuels. I mean, it is the most terrible crime. It's a horrible evil right now. because we can do it so easily. We have all the technologies, all the science to do it. We can do it rapidly. So those who push fossil fuels and more fossil fuel extraction and burning, that is the greatest evil, as far as I'm concerned, that I can ever imagine. And it's got to stop.
Well, that's definitely a powerful note to end on. I concur, and I think that it is really important that we've had this conversation to dispel. I think you both said it's so that, you know, we have this big distraction here. Oh, global dimming, but what's happening is people are focusing on this notion and not seeing the many millions of people who are dying every year because of the burning of fossil fuel. And I really appreciate learning about how younger people or children or babies especially are affected because of the alveoli. I mean, this is something that I never knew. So it's very informative, and it's actually quite frightening to think that these are the people who are targeted, so to speak, by this noxious poison in our air. We'd like to hear what your thoughts are on this global dimming conversation that we've taken you on a journey on. If you agree, if you learned something, put that down in the comments. We'd like to hear it. And if you really learned something, why don't you like this video? Because it helps us with not only with our channel, but it helps us with YouTube. We come higher up on the searches, and we like that because we think that we do provide valuable information. So go ahead and like, share, and most importantly, subscribe. We love our subscribers. And even if you're not a subscriber, go ahead, share a comment. What are your thoughts on global dimming, and what did you learn? We would really like to hear about that. And if you have more questions on this topic, please let us know what they are, and perhaps we can continue that in a subsequent video. And meanwhile, you know, we still have fires burning. We heard Peter and Paul talk about particulate matter 2.5. Take care, everyone. We're not getting the alerts that we should, that you need to stay inside when the PM 2.5 is high. Stay inside and watch out for yourselves and each other. We'll see you next time with the Climate Emergency Forum.